We're just giving some time for the participants to join. Wow, lots of people joining. Just giving a second for other people to join, to start. Just 1 minute. Well, I think this is a good start. And I gave like a couple minutes so just people could join. Welcome to the Better Buildings Summer webinar. Better Buildings is a program of the U.S. Department of Energy. Next slide, please. So today we'll have a webinar. I'm very pleased to have a webinar on clear the air, healthy indoor air for businesses and tenant spaces. Next slide, please. I'm Marcus Bianchi. I am a researcher at the National Renewable Energy Laboratory in Golden, Colorado, and I manage the space conditioning technology team of Better Buildings Alliance. Next, please. I'll be moderating this webinar. We'll have like a few updates from the space conditioning team. Then, we'll have like 2 talks, one by Professor John Zai of the University of Colorado in Boulder, and another one about Scott Williams, Williams Building Systems Engineering, all talking about different aspects of indoor air quality in commercial buildings. And then we have a Q&A to follow. Next, please. This is the space conditioning team at NREL. Myself, Dr. Michael DeRue, and Dr. Ryan Meyer, Kelsey Dombrowski, we all work together to put those not only webinars, but like a few documents together, all in space conditioning, to support the partners of the Better Buildings Alliance to have access to space conditioning technologies. We do have a mailing list. If you're interested in joining, please contact us. If you have questions, if you would like to actually participate and receive like updates, that's the email to join. Next slide, please. Just a quick few updates. We just got it published, the Healthy Buildings Guide for Small Business, which is actually in the background of this webinar today. So how can the small business owners and property managers ensure healthy air quality in their spaces? It kind of summarizes some of the latest set of recommendations. So this is downloadable. You can actually go into NREL and do a quick search and find this resource. Next slide, please. We do have a repository of information about HVAC. It's the HVAC Resource Map. The address, you can just search for it, but it's on the screen, and it goes through different aspects of commercial HVAC, describing the technologies and linking to resources that could be helpful to understand it deeper and go into more details. Next slide, please. We did publish last year the Decarbonizing HVAC and Water Heating in Commercial Buildings. It's a resource, the link is there, but it's a resource that could be useful for somebody to try to start thinking about doing a conversion to all electric solutions for commercial buildings. Next slide, please. We will manage the questions and answers for this webinar through Slido. So if you please go into Slido now, www.slido.com, and then you put the event code DOE, that will bring you to the questions and answers. I will be looking at those questions and answers and fielding them to the two speakers to make sure that we could actually address some of them during this webinar. Next, please. So a few welcome posts, so please let's go to Slido and look at them. Hopefully you have a chance to be there already. This is, what is your role, right? We even give mine here, so we have like a few answers there. Who is participating? And this gives us an idea, particularly not only for the speakers, but for ourselves and who usually attends those and are interested in participating. We have 39 answers so far, 41. It's getting there. Okay. Good. It gives like an overview of like who is doing that. Then next question. Yes. Where is your company or facility on indoor air quality improvement? Lots of just beginning. It's a good number. Thank you for participating. Next one. What is your biggest barrier to implementing indoor air quality measures? Yeah, I would think that cost would be one, but it's awareness that is there. Thank you. Thank you for responding. Next one, please. What space conditioning topic are you most interested in learning about next? And you have a chance of writing other, Excellent. Thank you. Next, please. So those are the other air exchange, low temperature hot water loop, filtration, and insulation. Thank you. Next, please. Okay, now we have our speakers. I'll briefly introduce them. So we have Scott Williams will speak after Dr. Jones-I. He leads Williams Building Systems in Engineering. Since he actually would give like a brief introduction to himself, I'll let him do that. Next, we have Dr. Jones-I. He's a professor in the University of Colorado in Boulder in the Department of Civil, Environmental, and Architecture Engineering. We have known each other for a long time, and he's doing like some very interesting work related to indoor air quality. I'll let him speak in his talk. Next slide, please. Oh, Scott will do beforehand. I guess I changed the order. Please, Scott, so please go ahead.
Okay, thanks, Marcus. And go ahead to the next slide. I'm just going to be talking a little bit about the application and options to optimize indoor air quality and energy performance. Go ahead to the next slide. My background is in a consulting engineer, originally designing HVAC systems, including ventilation systems for various building types. A portfolio owner, engineer, leader. I worked with Target for quite a while, leading their portfolio of build over around the country. And most recently, I've been independent consultant, owner's rep, putting sort of those design and owners hats on and helping owners in the healthcare area primarily optimize building performance through projects. And through this time, I have been involved since around 2008 with the Ashrae 62.1 committee, which is the ventilation for acceptable indoor air quality standard. I'll say that one of the highlights of my career was back in 2008, I believe it was. We met out in Golden, Colorado at NREL's offices with a handful of other retailers discussing maybe an option with the Department of Energy of creating a shared, an organization with a shared goal of helping save energy and look at sustainability. And that started the Retail Energy Alliance, which is sort of the predecessor, I think, to the building, better building systems. So it's pretty amazing what from the handful of retailers back then to where it's gone today, and the growth with through Department of Energy has been really impressive. Go ahead to the next slide. So the objectives, I'll go through some of the ventilation standards that are out there and some of the changes, recent changes, how to apply some of the different procedures that are acceptable in ventilation standards. I haven't, one of the procedures, the indoor air quality procedure has an opportunity to look at how do you balance the improved indoor air quality and energy performance, and how do you achieve both. And I can give some examples of how that was done at retailer over a number of years. It's always a challenge to try to balance the energy for ventilation, energy and comfort against indoor air quality, the codes, the risks for the design teams, and now with pandemic, the potential how ventilation impacts spread of viruses. So go ahead to the next slide. Some of the ventilation standards that are out there, I mentioned Ashrae 62.1. It's a standard for commercial buildings in the United States, but it's actually an international standard, so referenced throughout the world for its indoor air quality operations and design. International mechanical codes and other codes reference various forms. Some of them use parts of Ashrae standard. Some of them have their own specific requirements for ventilation. World Health Organization has ventilation suggestions, standards, and also limits on certain contaminants that are suggested in for indoor environments. There's the green building standard, such as LEED, and that's gone a long ways to improving building performance over time. And then state and local standards often supersede some of the other ones and have their own specific requirements that must be met for design. CDC has recommendations for ventilation, and that certainly came to the forefront in the COVID ventilation and some of the suggestions. I know I've working a lot with hospitals and use some of the CDC recommendations to appropriately isolate areas of the hospital during the COVID surges. And go ahead to the next slide. So what was learned during some of the COVID ventilation? I think it's been evolving over time as far as, is it airborne, is it not airborne? I think it's the consensus recently is that it certainly was airborne. And so the ventilation system has a significant impact on the spread of a virus. So some of the recommendations were looking at making sure that at least the minimum outside air rates are provided in commercial spaces, especially during peak occupancy. Filtration, improvements in filtration, MERV 13 or better is one of the recommendations. HEPA filters, which is a real high efficiency, 99.9+% efficient, certainly used in a lot of medical situations to better capture small particles such as viruses. Just to give you an example, MERV, the higher MERV number implies better filtration. A MERV 6, 7 is often used in commercial buildings, and that has a overall efficiency generally in the 30 to 35% range for capturing particulate. A MERV 13 is more like 80 to 85%. So it's pretty significantly, up to 3 times improved capturing performance. Portable filters in rooms have been shown to help significantly to both increase the air change rates and to capture locally contaminants. So it's also found it's really important to have effective air distribution and air change rates. So making sure that the air changes in the room are, in addition to outside air, just the overall air changes are high enough to flush the room effectively. And the system design has a lot to do with that as well. I'll say there's a lot of products, feature add-on devices that have been marketed for COVID. And as part of the 62.1 committee, we often see a lot of that as people wanting to propose including certain items within the standard. But I'd say the concern is a lot of those have minimal testing backup for them. And oftentimes the testing may not be done in a real world application. So some of the performance may not really be there once you put it into an HVAC system versus some of the lab tests that might show a different performance. So I just say that there is good add-on equipment out there, but it is really a buyer beware type of situation of some of it is probably not worth the investment. And then there's been throughout the COVID, and I just, this past weekend was the Ashrae 62 committee meeting in the summer meeting talking about the updates to the ventilation standard. There was a lot of discussion on if viruses such as COVID should be included in the Ashrae 62.1 standard, which they really aren't now. And I'll get into that in a minute, but you can jump to the next slide. So Ashrae 62.1, which is sort of the predominant ventilation standard, it's just read the purpose of the standards to specify minimum ventilation rates and other measures intended to provide indoor air quality that's acceptable to human occupancy and minimizes health effects, adverse health effects. So it's used for design and operation, such as in addition to the rates of ventilation, it will discuss how far exhausts have to be from intakes in order to avoid re-entrainment of exhaust, whether it's from a virus type of exhaust or a toilet exhaust or other types of systems. And I'll emphasize it's a minimum standard, and that viruses and bacteria are not included, in meaning that just meeting that the Ashrae standard doesn't mean that you necessarily have protection from viruses. And part of that is it's really hard to determine how much viruses is what's the goal in trying to reach a certain level of ventilation for viruses. And that's a difficult one in evolving science. But again, minimum standard meaning that you can certainly go above it, and it's meant to the design team and owner have to decide where to go with it. So there's 3 different procedures you can use to meet the Ashrae standard. It's the ventilation rate procedure. That's where you just take a area based, so many square feet for a certain type of occupancy, such as retail or a hotel or commercial building, and it has a CFM per square foot. And then based on the number of people that are expected, a CFM per person, and you just add those 2 numbers up, and you'll get your minimum recommended ventilation rate based on historic acceptability. There's the indoor air quality procedure, and that's what I'm going to talk about a little bit more today. That's more of a performance-based approach where you, by understanding the sources of contaminants in your space and what you're trying to maintain as far as limits of those contaminants, you can better balance your ventilation rate with indoor air quality and energy. And then there's the natural ventilation procedure, which allows you to bring in outside air directly through openings in the building to provide a natural ventilation approach. And there's been updates recently to the standard for that. And please go to the next slide. So recent updates, the current Ashrae 62.1 is a 2019 version. There's a 2022 version coming out soon. It's a continuous maintenance document, which means that their addendum are published continuously by the committee that will update that standard between cycles. And so in addition to the standard itself, you have to watch for addendum that might update it based on newfound information or correction of misinformation. Some of the changes recently, the natural ventilation requires consideration of outside air. So with natural ventilation, if you understanding your contaminants in outside air to make sure that you're using that outside air predominantly for ventilation, that you're not degrading the indoor air quality because of it. Humidity control is now being expressed more in dew point versus relative humidity, because dew point's more of an absolute measure of moisture in the air, and there's times when relative humidity could provide risks to condensation and indoor air quality issues due to condensation within the space. One of the changes with air cleaning devices that generate ozone are prohibited, where there are devices out there, electronic devices that would potentially remove one contaminant, but in the process create ozone, which is considered another contaminant. So that was considered not acceptable as far as meeting this Ashrae standard. And then the ventilation approach was had an option to simplify for design teams. There's more recently addendum AA was applied, and this was after many years improving the indoor air quality procedure. Ashrae now specifically specifies design compounds and limits for those compounds that should be looked at when looking in a commercial building indoor air quality, and it requires objective testing of the finished product to make sure that it's meeting the requirements as expected by the design. And it improved the equipment testing, both for measuring contaminants and for, if it's a filtration system, understanding how that system is tested. Go to the next slide, please. Now, why even consider a method such as the indoor air quality procedure? It is more difficult and more challenging to implement, but there's opportunities as well with that in using a performance-based approach. NREL did a study a number of years ago for the Department of Energy showing that in modeling, one retail store was able to save over 600,000 kilowatt hours per year in using the ventilation indoor air quality procedure for ventilation versus a prescriptive approach. And that retail store system, using the indoor air quality procedure since the late 1990s, was able to save over 100 million kilowatt hours of electricity in air conditioning and over 20 million therms of gas heat. So pretty significant carbon reduction as well from a sustainability standpoint. Opportunity while maintaining good indoor air quality. There's also reduction in latent load by not bringing in as much ventilation air during moist times. And it has capital cost savings by reducing the size of the equipment required to bring it to temper that ventilation air. Next slide, please. So how do you use an indoor air quality procedure, performance-based? You really need to understand the contaminants in the space or potential contaminants in the space if you're building a new building. And you can either try to remove those contaminant sources or through filtration remove them after within the space after it's completed. And then understanding design limits for those specific contaminants. And the new Ashrae standard and addendum does specify some design limits. There also is a subjective confirmation in the indoor air quality procedure. So both the objective and subjective requirements to make sure that it's working the way it should. So with indoor air quality procedure, you might have more air ventilation air required, you might have less, but by understanding your sources of contaminants and controlling them, hopefully it's just right. The next slide, please. Just in applying it, it's a challenge. Again, opportunity for design teams to use that. The way it was used in the retail chain was by testing multiple buildings in the chain under different climate zones at different times of the year. We were able to apply that to other buildings that had similar occupancies and zones. So say challenging, but the opportunities are there. Next slide, please. So I'm going to jump through this to the next slide just to show the opportunity. So with the performance base versus the prescriptive base, you can see that the amount of ventilation required in the retail store because of source control and cleaning procedures was significantly reduced versus the prescriptive rate. So had opportunities for energy and capital savings over time that were significant. Go ahead to the next slide. So for future considerations, and as more individuals or groups use indoor air quality procedure, that information goes back to the 62.1 committee, understanding what contaminants are in buildings and how to better control those. Defining good indoor air quality is really a challenge, especially now with COVID as part of and viruses as part of the equation, or potentially. Sensor technology continues to improve, so we can measure things. That's a better way to control things. And filtration technology continues to improve so once we know what contaminants are in there, we can potentially remove those with filters. Next slide. So in conclusion, the green building practices have greatly reduced contaminants in the building material itself, and then in the materials that are brought into the building. So using the indoor air quality procedures allows you to take advantage of some of the improved construction practices and improved indoor air quality to better match the ventilation rate with the contaminant levels. And as we look at ultra-low building energy use in the future, I think it's more important to focus on ventilation as one of the major sources of energy use. And then with COVID, as mentioned, good ventilation is really a key to helping reduce the risks and spread. And go ahead to the next slide. Source control. So I've always been an advocate where if you can understand what contaminants are in your space, and in the retail area, formaldehyde was one of the primary contaminants and it has dropped significantly over the years because of demand from the end user to reduce that. But by reducing it at the source, you eliminate it through the entire supply chain, including what the ultimate consumer brings home into their homes, and eliminate that potential indoor air quality concern all the way through. So I think that's source control is a great way to focus. So meeting the challenges of trying to give good indoor air quality and energy performance, you really need to look at it engineered. It's worth looking into a more engineered system than the prescriptive approach might provide to better balance the energy comfort, indoor air quality, codes, risks, virus control, other things. So it's maybe a little bit more work, but I think as we go forward, it will be a necessity. Next slide. So thanks. I think we'll have some questions later on.
Go ahead, John.
All right, thank you. Thank you, Max, for inviting me here. And my name is John Zai. I'm a professor in architecture engineering department at the University of Colorado Boulder. So one of my research area is indoor air quality. I'm a fellow of Ashrae and ISIQ and IBPSI. Today I'm going to share some research we conducted in the last few years, talk about mitigation COVID-19 in public commercial spaces. Next, please. So as we understand, the three mechanisms as indicated by WHO and the CDC for the COVID transmission. So number one is close contact because they're large droplets spread out when people are talking, coughing, that typically transmitted within 6 feet. And also there could be small particles transmit through the air, which can go beyond 6 feet. And certainly there's also surface contact with the thermite. Those are three general widely accepted mechanism by all kinds of professionals. As CDC indicated, most infections happen, like more than 90% cases happen indoors. The outdoors is less than 10%. Actually, if you look at those outdoor cases, more than 8% of outdoor cases happening for those gathering events. If we remove those gathering events, we'll find the outdoor environment, typically we have less than 1% of infection cases, which relate to the mechanism because we have typically have a large social distancing of high ventilation and less smaller concentration virus. Next, please. So yeah, when we look at all the droplets released from all kinds of human activities, for example, look at in talking, typically we release about 3,000 droplets per second, and in which have about 200 virus particles. And if we talk about sneezing, which is 10 times more, then talking, and the travel distance will get into 26 feet. Next, please. But if we look at among the 3,000 particles, droplets from talking, for example, we find that actually more than 80% of particles are larger particles, which means they're more than 25 micron. Most of them are falling between 50 to 100 micron. What does that mean? Those particles can quickly drop on the floor, typically within 6 feet. That's exactly why CDC recommending the social distancing away from 6 feet. However, we do have about 5% of small particles, which is typically less than 5 micron. And those micron, we did a calculation that can transfer more than 2,500 meters if there's no any boundaries or barriers. So those are the concern for another bunch of scientists talk about airborne transmission, although they have a smaller probability, but they do exist in this pandemic. Next, please. Next. Yeah, so if you look at this famous equation, it's called Weiss-Riley infection risk. I don't want you guys to look at the equations. I know as a professor, I always like equations, but in this case, really want you to look at what all the parameters affecting the infection. If you look at the bottom part, those all relate to emitter side, the infector side. So you look at what's the concentration of virus exhaled from the emitter, how much air emitted, which is related to the emitter's activities, and also depending on the exhaled virus quantum number, which is the minimum number of virus going to cause people sick, the average, right? So this, for example, this number will be significantly different between Delta and Omicron. And this is from the source side. And then we talk about the sick side, this about receiver. So really talk about the concentration of virus at the receiver and also what the activity of a receiver and how long the receiver stay in that position. So that's about all the sick control. If you look at the next slide, please. So this is just like Scott mentioned, this is in every single textbook, classic book for air conditioning textbook. So those are traditional and still current measures we can use to control pandemic. The first one is source control. That's quarantine, whatever. That's isolate, remove the source. That's the number one most effective way. And the second one will be the ventilation. If the air is clean, then we can use the clean air to dilute the infected air. That's a second solutions as we talk about natural ventilation, mechanical ventilation, ACH, etc. The last one is if the air is not clean or not sure whether clean or not, then we have to use purification. All kinds of UV cleaner, portable air cleaner all belong here. So still after this 50 years, during this pandemic, we still talk about this traditional control measures. Next, please. So let's look at the mask. That's the first PPE, the personal protection equipment. That's the first control for the source control and all for the receiver's control. Here, I just want to indicate If you look at the large particle, right, we talk about large particle like more than 25 micron. Actually, when you look at homemade 100% cotton t-shirt mask, they're pretty good. If you look at the 97% efficiency for large particle, remove large particle. However, those masks are not good for removing small particles, only have a 51%. However, if you look at a surgical masks, they're pretty good as good as a 95 mask is, in that sense. Another thing interesting is CDC recommended bandana at the very beginning, right? But if you look at those numbers, even for large particle, bandana doesn't do a good job. It's only have a 44% protection. That's why at the very beginning, I personally strongly recommend even use a homemade mask. Will be better use bandana. Next, please. But we know mask can help. I can show you results later. It does show well protection to use the mask. However, a lot of circumstances we cannot wear a mask. For example, we go for dinner and it's for some special events, or the quality of mask may not be good, and the way people wear masks may not be perfect. So we still have to talk about engineering solutions. How do we mitigate the infection risk? Next, please. So this all the Scott already mentioned. Those are all the recommendations from Ashrae during the pandemic. A bunch of stuff I don't want to repeat it, but just highlight a little bit. Continuous run, 2 hours pre-occupancy and post-occupancy run the air, maximize the outdoor air, use the energy recovery to save energy, 40 to 60% RH, 68 to 75 degree Fahrenheit temperature, use MERV 13. Adjust the filter frequency and use a portable air purifier. That's pretty comprehensive and still be used in industry for most commercial retail spaces. Next, please. Here, I just want to share some results we've done for a bunch of buildings. This is just the commercial buildings. We also do for retail or do the hotel for schools, etc. So this is one example. So this is the middle rise large office buildings with 134 occupants, and the people stay there for 9 hours with full capacity. There's no reduced capacity, it's full capacity. And we assume there's one person sick in the first floor core zone. And we compare with R not equal 1, and most of you know R not equal 1 is a threshold. If more than 1 means one person can infect more than one person, right? If less than 1, that's infected less than 1%. So the 1 is a stable position. We use that as a threshold to evaluate whether the measures works or not. So the shaded line, you see the white shaded line means wear mask plus engineering solutions, and the other columns just the engineering solutions without a mask. So in this special case for commercial building full capacity, we find it very interesting. All engineering controls with mask wearing can keep infection from propagations, even with the base case. We have MERV 8 plus 0.65 ACH basic design. It works pretty good. However, if we remove the mask, nobody wear mask, now we find most of them cannot meet the R not 1. So only the case with 100% outdoor air plus room level UV can help. So that's a recommendation. Without the mask, this highlights the importance of mask, but also in this case, we need to enhance the ventilation rate and also use the space cleaning device. And also one of the interesting findings, although Ashrae recommending MERV 13, in our research, we find a MERV 11 actually is already pretty good. So when we upgrade from MERV 11 to 13, the marginal gain is much less than we expected. Next, please. So this is another example showing the classroom, small classroom, 1,000 square foot with 37 students, and the teacher is sick. Teacher will be there for 7 hours. So we do care about the exposure time as we speak early. So in this case, look at all these cases with shade lines. We find that even with mask can now help preventing the infection. We have to use air cleaner, at least a 2,000 CFM air cleaner with mask can keep the infection from propagation. Well, if students don't wear mask, then we need a much bigger CFM air cleaner for the space we talk about 90,000 CFM. Keep that in mind. Typical floor air cleaner is about 300 CFM. So how many cleaners we need for the space? In most cases, are realistic. In this case, we have to talk about other solutions like reduce the capacity, etc. Right? This is a small space for 37 students. Next slide, please. So we summarize all the cases from office, school, retail, hotel. Very interesting. We find that there's strong correlation between the exposure risk percentage versus the exposure time divided by total supply airflow rate. We're not just talking about ACH. We talk about exactly how air is supplied to the space. So these two lines, one is represented, treat the whole building as a single zone, single one box. The other one is treat multi-zone, that like I have a box, right? Different conference room from different from office space. So, but they follow pretty linear relationship like I show here. Next, please. And then we did some physical testing in the real restaurant. And in this some animation, you can see the first one to the left, that's the air purifier is off. So you can see when people talking, all the droplets can spread out even under the central air conditioning systems. Spread out, it can affect the people at front, opposite to the emitter. But whenever we turn on the full purifier, either put on the full and put on the site, both of them can absorb most of the released contaminant, as you can see. Click, please. And then also we did quantitative analysis. Those are talk about the particle, number of particles accumulated. We find the people, one is an emitter, the two is the opposite position. You can two and a 4 basically release, get a lot of infection. But if we use a 4 units or the 4 at the site units, we can have a good protection. We also try the table unit. Those are air cleaner. We can put on the table, the small unit. Typical units 110 CFM. We can put the 5 table unit on the table, and we can see what happened. It does also help reduce the infection. Next, please. And further, we did a CFD analysis. This is the computation of fluid dynamics for the whole restaurant, full capacity, 177 occupants. And you will see the supply air from the ceiling, the slot supply, and the central, the return from the ceiling. And also we test to put 8 floor air purifier, as you can see over there at the site. And if on each table, we put also a table unit, a small table unit. Next, please. So as you can see, the indoor air is very complicated. There's a hot plume from the human and the cold jet from the diffuser. Depending on where we are, the air movement and mixing is complicated. It's not just as mixing as we wished. Next, please. So if you look at the CA is central air, the B is central air plus flow unit, C is a plus flow unit, table unit. So if you look at the infection, probability of infection, we use 1% at the breathing zone level, which is 1.1 meter height from the floor. So with only central air, you will see most of the areas will be covered more than 1% infection risk. Well, if we use a floor unit, the zone is reduced, infection zone is reduced to the corner. If we add to the table units, the zone is much smaller now. Next, please. So this is just some animation showing, the first one is showing no air purifier. You will see the droplet released from the talking because of buoyancy. The hot plumes tend to go up. When you get into the middle way, because the cold air pushing down, so you will see spread out to the droplet to the space. It goes everywhere. And the right hand, that's the 4 unit purifier. In this case, you can see most of the air or contaminant will be absorbed into the floor unit. Next, please. And this, you look at this with the table unit, the same thing with the table unit here, we'll see this table unit can absorb the contaminant towards the diffuser, right, and clean the contaminant. And you can see the velocity vector, most of the air flow towards the diffuser. Next, please. And we tried an even bigger case. This is the ballroom case with a banquet with 1,320 people. In this case, all the supply from the ceiling with a full outlet at the back wall. And we tested for 3 different locations for contaminants. Next, please. So this animation left, if we click on it, you will see without a portable air cleaner, it's only central air, you will see the contaminant really spread out across the table and even go to beyond to the other tables. If you click on the right, you will see with the table unit now, the airflow pattern and contaminants distribution is totally different. You will see a strong jet flow from the table upward. If you look at the quantitative results again, the purifier only handles 12.36% particles. However, you see the reduction of deposition on the bodies reduced about more than half. And if you look at the ceiling, it's actually getting to about 50% deposition. This is because the strong jet flow from the diffuser actually pushing the contaminant towards the ceiling. This is something we didn't expect at the very beginning. We thought mostly we should count on the cleaning effect of the purifier, but interesting, the air jet from the purifier actually push the contaminant towards upward. Next, please. And this again showing the velocity vector and the PI contour. As you can see, the top 3, the CAB, those are just the central air system only. You will see how this contaminant can spread out. And the bottom one, the CATB, that's with the table unit, is confined on this table only. Next, please. So really, after this, just like Scott mentioned right now, there's a big debate in the field. People talk about those on the medium discussion, talk about what is the key? How do we design next generation buildings? What about the new air standards, right? We don't have an answer for it now. It's actually a lot of debate on it. Next, please. So one thing we need to talk about, if this is a study done by a company, they look at if we use 100% outer air to reach 5 ACH, you will see significant cost increase and the carbon emission increase compared to the business as usual as a current standard, which is not acceptable. This you can see for all the climate zones, right? You have huge increase. Other than that, we can use a recirculate air, which is clean air, rather than 100% outer air. We can reduce this load very significantly. Next, please. So the main takeaway from this talk is we have to consider both ACH and the total air change rate, or the total change air flow rate, not just ACH time volume, and also talk about exposure time. And we have to consider all clean air, not just outer air, fresh air. We have to talk about recirculate clean air as a part of a solution. And we have to look at the portable air cleaners. Certainly we have to look at the adequate capacity. And the last one, we have to look at indoor air distribution. A lot of studies assume the space is perfect mixing. Unfortunately, they are not. They're strongly case dependent. Like you said, the jet flow from the air purifier can actually change the air flow directions and the change the infection risk. Next, please. I believe that's it. I'm right on time. Thank you, everybody.
Thank you so much, John and Scott, for the presentations. We'll get some questions. I mean, I think I posted on the chat, but there's I'm collecting some of those questions in the Q&A part of Slido. So if you have questions that would be interesting to post to the speakers, please post it there. I actually was looking at them, and I responded to some of them. So I replied with links to the guide itself that we published and to previous presentations. One question that I was asked, and I in like more than once, what about energy consequences? Cost impacts of improvements in IAQ, and what about legal liabilities? I don't know if like either one of you would like to comment on that. I would just started by saying that NREL last year made a series of simulations trying to determine what are the impacts of the Epidemic Task Force recommendations in buildings energy use, and I posted that too. Please, one of you who would like to address that.
I'd be happy to go ahead and start.
Please.
Certainly, there is an energy impact, and that has to be looked at, because using more energy also has a detriment to outside air quality by with carbon and others. So indirectly does impact indoors. There's a balancing point there that has to be understood. In addition to the energy would be just even systems, because you can't just automatically increase your outside air rate on existing systems that weren't designed that way for capacity, and or even sometimes add extra filters that your fan systems may not be able to handle it. So there's a lot of impact. I mean, now it's just understanding how to do it, and then it's how to apply it is going to be a whole new ball game, especially trying to do it in existing buildings.
Thank you.
Yeah, I can add a little bit on it. From the fundamentals, we know if you double the speed, right, the velocity, or double the volume flow rate, you basically 4 times the delta P, the pressure drop. And you talk about the fan power, that's the cube, which is 8 times the energy use. So what I'm saying is, if you want to increase total air change rate, there's a huge implication to energy consumptions. Another way to do is change the filter, like Scott mentioned, it would change the MERV 13, but there's also a consequence of that to the energy saving, because you increase the MERV rating, you increase the pressure drop. So you have to increase the fan power. Again, the mechanical fan in the whole building takes about a 40% of total electricity use of a building, okay? So 40%, you think about it, it's very significant. Now, if you want to increase that energy, if you go to 60%, that's a huge burden to the building owners, operators. So do have to consider the consequence of this IAQ procedures. And also the other things like Scott mentioned, natural ventilation. Actually, a lot of countries use that. China, UK, they're already promoting that, even use the natural ventilation for hospital. But unfortunately, nothing passed in the US, right? We're still demanding mechanical ventilation for some purpose. But it will be very interesting, the Ashrae open the door to look at another opportunity for natural ventilation.
Just a follow-up question about that, just because it's my curiosity. What about, when you have issues like the big fires that you and I, John, have been facing at times? Yesterday, my outdoor air quality was pretty bad. So when you talk about natural ventilation, you have to account for that. How do you do that?
Well, that's a great question. Like I said, we have to count on clean air, outdoors clean, that's assumption, then we can use ventilation, right? That's sure. Yeah. So, but for that case, if the outdoor is bad, like in Beijing, Shanghai right now, people talk about PM 2.5, terrible. In that case, the recommendation will be close the window, doors as tight as possible. Don't even think about opening it, but we still need a fresh air. In this case, the purifier will be the key. So now we can turn on the purifier, the portable purifier, or just do 100% recirculated air, okay? So we count on the filters or the UVs to clean the contaminants. Certainly this air doesn't provide additional oxygen. It doesn't provide that, but it will certainly clean the contaminant. That's the solution number 3, as I mentioned, the classic solutions.
Excellent. Not a question that had a lot of thumbs up. Any advice for implementing IAQ measures across more than a dozen sites? So like if you have to consider multiple buildings, is there any particular advice on how to do that? Different from like just dealing with a single building?
Well, in that case, I will refer to the Ashrae recommendation that I listed. That is the pretty generic for most of our commercial buildings, like the schools, retails. Although Ashrae also developed those area, the building specific recommendation. They have for restaurant, I believe for schools, reopening guidance. But the one I listed, those are general recommendations. For example, keep a right temperature range, RH range, and maximize the auto air rate, and change the filter to the max allowed it for this building. Stuff like that. I think that's the general recommendations.
Thank you.
And I'll just add the indoor air quality procedure, as I mentioned, works well with multiple sites, because it recognizes that if you understand, if the sites are similar in a lot of contaminants and operations, what you find in one site might apply to other sites. So you can do extensive testing on a subset of the sites and perfect your performance, and then apply that to other sites. And so it allows the owner to sort of spread out the cost of maybe extensive testing to multiple sites across their chain or portfolio.
Thank you.
Yeah. Another thing I wanted to add is, although I highlight the importance of non-uniformity of the space here, but most of the small spaces, they're pretty good mixing. That's why a lot of study Ashrae guidelines are based on the perfect mixing assumption, like a small office and a small restaurant, all the stuff. They're pretty good for those general assumptions.
Excellent, thank you. One question that actually I find it pretty intriguing. Let me see if people are like clicking. So, okay, here. Can you say more about source control? What should I eliminate from my space to improve indoor air quality? How do you do source control in commercial buildings, and what are like the prioritization that could take place there?
Let me give a first try, and Scott can follow. The source control is most effective. Let's that in the special pandemic case, that's a sick people, right? People got sick, then try to have them go home. Don't even. That's why we all the companies have this policy. If you don't feel comfortable, feel sick, might be sick, don't even come to the office. That's the number one. And a lot of offices do the screening, right? Like at the airport, they do measure the temperature, all the stuff. That's the way to protect it. But those are just for virus pandemic. But if you talk about general contaminant sources, for example, VOC or the PM 2.5, those are stuff we already established pretty well knowledge on the potential sources. For example, the VOC can come from the furniture, the carpet, right? The painting materials, the cleaning solutions, etc. So we try to eliminate that at the first place. When people choose the materials for construction or to buy the furniture, we have to make sure that we buy the low VOC or no VOC painting, stuff like that. That's all called source control.
Thank you. Scott?
Yeah, I agree with that. It's as I mentioned, the green building push has done a great job of reducing VOCs and a lot of construction material. And we saw that during testing over the decades that the contaminants have gone down significantly, even directly after the opening of a new building. It was no longer a need to really flush it out to get rid of those construction contaminants. And then also, even say, in my experience with Target, a lot of the contaminants were coming from the products that were being sold. And that also has improved greatly over time because people were requesting reduced contaminants in their clothing and other products, furniture that you put together. So that again has improved greatly. So that's a good opportunity for source control. Just the demand from the consumers all the way down through understanding what are the contaminants, even as far as cleaning materials that are used in the building, or equipment that might be having carbon monoxide if it's a propane burnisher, for example, in a store. So there's a lot of potential sources, and by measuring it, you can find what those might be and then hopefully address them.
Thank you. We are out of time, and I'm just going to give the last minute to the organizers to actually, show what's next. Thank you both speakers for presenting, and thank you for the participants. So there are like a few webinars, in the future, please visit and find, their contents. Thank you so much for participating.